Okay, so we know that we're looking at a parabola, and we know because this thing right here, there's no negative over there. This means that this is going to be a smiley face parabola. Okay, this is going to be a smiley face parabola. So we know that we're going to draw it. We're going to draw it facing upwards. What is my y-intercept, guys? What is my y-intercept? Who can tell me? What is my y-intercept going to be here? Good, excellent, Nico, that's it. It's -4. You're very welcome, Pascal. Good, it's -4. So remember, when we look for our y-intercept, guys, we need to make x equal to 0. And if I make x equal to 0, I'm going to get y is equal to 0 squared minus 4. And that's going to equal -4. So my graph is going to go straight through the point -4, or it's going to go through the point -4 and 0. But I also know that, what do I know about this point 0 and -4? It's also the what? Does anybody know what it also is? Who can tell me? That's it, Asbonge, good stuff, amazing, awesome. Yes, it's also the turning point. Now what I need to find, guys, is my x-intercept. Can anybody tell me? What are my two, and I'm telling you now that there are two x-intercepts. We can find them. Good, sure. Asbonge, amazing, awesome stuff, good. It's going to be 2 and -2. Now, the way we would find the x-intercept is we would make y equal to 0. So I would then have x squared minus 4 is equal to 0. And if I look at this thing, this is actually dots. Okay, this is actually dots. So I'm then going to factorize this into 2 brackets. So I'm going to get 2 brackets equals 0. So I'll have x plus 2 and x minus 2, like that. Therefore, x will be equal to -2, or x will be equal to 2. What that tells me is that these 2 points are the points over here, -2 and 2. And then I can draw my smiley face parabola from there. Okay, and that's what my parabola needs to look like. Okay. So we're going to be looking at a couple of questions on trig graphs, which are a big part of paper 2. Okay, so we're going to be drawing the following graphs over here. We're going to be sketching the graph of y is equal to sine x, cos x, and tan x. Who can remind me, these 3 graphs, what do we call these 3 graphs, guys? Just the normal graph of sine x, cos x, and tan x. What do we call them? Anybody remember? They are trig functions, Akakang, yes. But when we draw the typical looking graph, yes, or bio, that's it. When we draw a typical looking graph, we call it the mother graph. Okay, because all other graphs are just variations of this graph. So we always have to ask ourselves, what have they actually done to the mother graph? That's what we're always going to be asking. All right, so on a set of axes, just like that. Okay, I want you guys on the same set of axes. I would like you guys to sketch the mother graphs, okay, of sine, cos, and tan. You can use different colors to draw each of them. I'm going to give you 2 minutes for each, so you guys have 6 minutes to sketch each of these. Okay, to sketch all 3 of them, not each, all 3 of them, 6 minutes. And then we will get to looking at what they should look like. I want you guys to note one very important thing. They have given us, yep, on the same set of axes, Nico, they have given us that our x needs to go from -180 to 180. That means that my graph isn't going to make it all the way to 360. Okay, it's not going to get all the way to 360. It needs to stop at 180. Okay. So my graph needs to stop on this side at 180, and then you need to draw it on the negative side at -180 degrees as well. Okay, so make sure, remember all those points that we need to consider, guys. We need to consider 0. We need to consider 1 over here. We need to consider -1 on this side as well. Okay, and then here in the middle, we're going to consider the 90 degrees. And because we're not going to get 270 and 360, we're going to consider negative 90 degrees instead. Okay, so use your sign. Remember, you're going to replace x first with 0. So you're going to go to your calculator, type in sign of 0, get an answer, and then sign of 90, get an answer, sign of 180, get an answer, and then you're going to go to sign of negative 90, get an answer, and sign of negative 180, get an answer, and then you'll be able to plot your graph. Okay. Yeah, actually, I agree with you, teacher Nels. It's up to you. You can choose. One minute, guys. All right, peeps, let's start looking at these graphs. Now, I'm going to, before we even start, I'm going to remind everybody that ma'am is not an artist. before we start judging ma'am, please guys, remember, ma'am is not an artist. Okay, let's start with the graph of y is equal to sine x. Okay, so sine of 0 degrees is going to give us 0, and sine of 1 will give us 1. Or sine of 90 will give us 1, sorry. And sine of 180 will give us 0 again. So that's the part of the graph we're going to draw on that side. Sine of negative 90 will give us negative 1. So we'll be over here. And sine of 180 will give us, negative 180 will give us 0. So my sine mother graph over here will be drawn like that. Okay. So that's the first sine graph that we're going to have over there. And then let's look at the sine of the graph of cos. Okay. Now I know that cos of 0 is going to be 1. Cos of 90 degrees will be 0. And cos of 180 will be negative 1. So we'll be over there. Okay. Cos of negative 90 will be 0. Okay. And cos of negative 180 will be negative 1. Okay, so my cos graph will look like that. Okay. I know it looks like an upside down cos graph, but it's actually not. It's just because it goes to the negative side as well. Okay, and then my tan graph, who remembers there's one particular thing about a tan graph that doesn't exist on a sine graph or a cos graph? Anybody remember? Those things, you also get them on a hyperbola. Anybody remember? Yes, good, Atihan, amazing. Good. It has, well, not horizontal asymptotes as long in this case, it has vertical asymptotes, the ones that go up and down. Okay, so it's going to have a vertical asymptote at 90 degrees, and we're also going to have another vertical asymptote at negative 90 degrees. Okay, both of these problematic. We're not going to get anything over there, right? But we know that tan of 0 is also 0, right? And instead of looking at tan of 90, because that's going to give us a problem, we're going to look at tan of 45. We're going to look at tan of 45 over here. On this side, tan of 135. Okay, and on this side, tan of negative 45 degrees and tan of negative 135. Okay, so I know that tan of 45 is 1, right? So my graph on this side should go up like that. And I know that tan of 135 is negative 1. So my graph needs to cross there, and tan of 180 is 0. So my graph should look like that. It's almost like it's split in two different parts, right? Over here, tan of negative 45 will be negative 1. And then we'll have a problem there, and tan of negative 35 will be positive 1. So my graph will look on this side will look like that, and on this side will look like that. And remember, they're approaching our asymptotes, but they're not actually touching us. Okay. Actually, teacher Nels, don't you think I drew a lot better today? Hey? My drawing isn't that bad today. It's pretty decent. I think.
Yeah, even the colors are giving. I'm like, ooh.
Thank you. Thank you. I did the right things today. I feel like my drawing is getting better.
Yeah.
Okay. All right, guys. Okay, let's look at the next couple of questions. These are just questions that we should know about any graph as we're looking at it. Okay, what is the period of y is equal to sine x? The normal graph, like the mother graph. Remember, we're talking about mother graphs here. What would the period of the mother graph of y is equal to sine x be, Jasmine?
No, I had a question.
Yes.
The blue lines on the graph is the tan graph.
Yes.
Thanks.
Okay, no worries. Okay, yes, the blue lines are the tan graphs. Okay, all right. So remember, guys, what does the period refer to? The period refers to How long does it take for me to draw a full graph? Okay, so if we had to look at the mother graph of a sine graph, how long does it take me to draw one full graph of sine? From what degrees to what degrees, or how many degrees does it take to draw a full sine graph? Anybody remember? Oh, I'm not 180. Remember, it's a sine graph. It's a sine graph, guys. Sine graphs normally go up and then back down, and then they need to start where they started again. Yes, Jasmine.
Negative 360 to 360 degrees positive.
Okay, cool. All right. I hear what you're saying, but we don't need to include the negative 360 part. Okay,
Oh.
so how long does it take us to draw a full one? It will just take us 360 degrees. Okay, beautiful, excellent. That's it. That's all. So the period of a full sine graph is 360 degrees. Okay, that's how long it takes us to draw one full sine graph. What about the cos graph, guys? How long does it take me to draw a full cos graph? That's it, Ovayo. Excellent. That's it. It takes 360 degrees to draw a full cos graph. Okay, beautiful. It's 360. But what about a tan graph? A tan graph isn't going to be the same, is it? How much would it take for us to draw? How long would it take for us to draw a full tan graph?
180.
Beautiful. I hear you. I see you, Ovayo, and I hear you, Jasmine. Beautiful. To draw a full tan graph, it takes 180 degrees. Okay. Excellent. And we can see it right over here. Okay? I've drawn the full graph between 90 and negative 90. In between these two, that's 180 degrees put together. All right, so we need to remember that. All right, let me ask the next question. What is the Asbonge, not necessarily. It's not always constant, and I'm going to show you when we start doing some examples. Okay. Okay. What is the amplitude of a sine graph? Remember, amplitude is how high? How high up does my graph go? Okay, if I look at it from 0, if I start from 0, guys, if I start from here, from 0, how high up does my sine graph go? Good, that's it. Excellent stuff, guys. Amazing. It goes up 1. Good, it does. So the amplitude of my sine graph is 1. Right? We can see this because we'd never ever be able to get any value above 1. I'll give you guys a quick hint. If you pick up your calculator and you type in the shift cos of 1,5, do that on your calculator and tell me what it says. What does it say? If we type in the shift cos of 1,5, what do we get? Good, Yeleti. Yes, it's going to give you an error. It's going to give you a math error. Okay, because the cos graph, as you can see, only stops at 1. It doesn't go any further up than 1. Okay, the only time it will go further up is if we do that, if we put a 2 in front there. Okay, if we put a 2 in front, then the whole graph stretches by 2. But for now, the period of a normal cos graph is always determined by this thing here in the front. And we know that when cos x is sitting on its own, the number right in front of it is 1. So the amplitude of a sine graph and a cos graph normally is 1. Now, my next question is, does a tan graph have an amplitude? I'll give you guys a hint before you even answer the question. Does a tan graph have an amplitude? Yes or no? Ooh, absolutely not. No, it doesn't, because it keeps going. So you could even type into your calculator, shift tan of 17. You're still going to get an answer. Okay. You can make it as big a number and or like as big a positive or as big a negative number as you want, you will always get an answer out. Okay, because our cos graph does not have it doesn't have an amplitude. It keeps going forever and ever in both directions. Okay, the only thing is you will never get 90 or negative 90 or 270 as an answer. All right, okay, now let's look at our first example that we've got over here. Now it says here, the diagram below represents the graphs of sine or f of x, a sine x, and g of x, b cos x. So what did we say these two things are again, this a and b? The things right in front of my sine and my cos. What do we call these two things? What do they determine? Anybody remember? I literally just said it. Literally 3 minutes ago. I said it 3 minutes ago. Anybody? Somebody? Okay, think about it, guys. Oh, thank you. Hi, Patu. I was about to give another example, but then Patu came through and rescued everybody. Yes, good. This is the amplitude. We've just spoken about it, guys. The amplitude. Okay, so this again tells me how high up do my two graphs go. So at some point, we're going to have to figure those out. And then remember, we also need to think about the period. Let's look at the period before we even continue, guys. How long does it take me to finish the sine graph and the cos graph up on the screen? What would my period be? How long does it take me to finish each of these graphs? Anybody? Good. Hi, Pachi. I feel like you just got here. Good. It takes 360. Excellent. Okay, 360 degrees to finish one full graph of the both the cos and the sine graph in this case. Okay, so now it says write down the values of A and B. Okay, I want you guys to take a minute, think about it, look at the two graphs, okay, and answer question 4.1 over here. Have a look at the two graphs that I've put in front of you and tell me what is the values of A and B. Remember, we just said A and B is the amplitude. So think about it for 2 seconds. Look at how high up my two graphs go and tell me what is the amplitude. You can put the answer in the form A is equal to something and B is equal to something, because they want to. Okay, good. I'm getting a couple of answers. I just need you guys to remember something. Yeleti, you're correct. Reabetsu, you are spot on. Pascal, you've forgotten just one thing. Okay, one very important thing. Okay. But everybody else on point. Okay, Reabetsu, well done. Yeleti, just answer the second part for me. You've given me A. What about B? Okay, Mbali, check your answers again for me, my sweetie. Just have a look. Okay. While you guys are trying to figure that out, I'm just going to do something very quickly here. Very quickly, I'm just going to do this. And I'm going to remind you guys. Okay. Then okay. Or it's 1 and 2. Okay, no, not quite. And I'll explain why in just a second. Okay. All right, guys. So that's 90. That's 180. This is supposed to be 270 over here, but it's clearly moved, and that's 360. Okay, so okay, so over here I've drawn the mother graphs. Okay, So let's start with the value of A, guys. Now, A belongs to the sine graph. And where do sine graphs normally start, guys? Do they normally start at 0 or at 1? At 0 or 1? Good, good, guys. So we know that our sine graph needs to start at 0. Well done, Rebetu and Patru. Good stuff. Our sine graph would need to start at 0 over here. Good. And then would our graph go up, our mother graph, would it go up or would it go down? The normal graph of sine, would that go up or down? I'll give you a hint. The graph of sine is this one that I've drawn over here. Is it supposed to go up or is it supposed to go down, guys? Good, good. Okay, it's supposed to go up. It's supposed to go up. But if we look at this, it's actually going down. So what does that actually tell us about this value of A? Is it going to be positive or negative? Positive or negative? Negative. Ah, now Patu's getting it. Okay, good. It needs to be negative because usually it would have gone up, but now it's going down. And now look here, guys. Normally, the mother graph would stop and start going down at the point 1. But now let's look at our graph. It goes down all the way past -1. And where does it turn? It turns at what? At what value does it turn at? -2. There we go. Okay, it turns at -2. And Patri, yes, I see you at 90 degrees, where it should have been at 1 at 90 degrees. It's now at -2. So this A value is actually now negative, and instead of it being 1, it's now 2. So our A value, A, is equal to -2, right? Okay, cool. So we've now figured out that A is -2. Just give me a thumbs up if you understand what I've done, what Teacher Coco has done with that section over there. Do you guys now see how we got the answer for A? Give me a thumbs up if you understand. Okay, I am happy to explain again if need be. So just let me know. Okay, Asbonge, I'm happy to do it again. All right. So remember, Asbonge, I just asked you to draw the mother graph. Yes? We've just spoken about the mother graphs. Okay. So if I asked you, Asbonge, let me draw it better. Maybe it's my drawing. I feel like my drawing makes people blank. Okay. If I asked you to draw the mother graph of sine, this is what you would do. You would start at 0. Okay, remember the points that we always consider. We consider 0 and 90 and 180 and 270 and 360, right? Then we know that when we're drawing the mother graph of sine, at sine of 0 is 0, and we'd go all the way up to 1 at 90, come back down to 180, that would be 0, go down to -1 at 270, and then come back up to 360. Guys, I tried. Okay, so this is how the graph needs to look. Okay, this is how the graph needs to look. But now, if we look at the graph that they've given us over here, it starts at 0. They've given us the sine graph at 0, but instead of it going up towards 1, it starts going down. Where the mother graph would normally be positive going up, it starts going down. So that automatically means it's going to become negative as we go down. It'll be negative. Okay, it'll go negative. And then you see here that our graph should actually turn at 1. It should turn at 1. But this one doesn't turn at -1. It's been flipped over. But instead of turning at -1, it now turns at -2. See that? Which means our graph has been stretched from 1 to 2. It's been stretched like that to 2. But instead of being at 2, it's been flipped. So it's actually over here at -2. Okay, so that value at the front is exactly what's happened to that graph there. Okay, so it's at -2. So our A value is A is equal to -2. As long as that makes sense. Awesome, awesome stuff. All right, what about B, guys? What about the value of the cos graph? What would our cos mother graph look like? Good, Hachi, you've got the right idea. But remember, they don't want you to say that one is like 1 cos x. They just want you to tell us, state the value of B. How much would B be equal to? Good, because B looks exactly like the cos mother graph should look. It starts at 1 and goes through 0 and goes down to -1 and back through 0 and up to 360. So this is exactly the same. Okay, B is equal to 1. Good. B is equal to 1 because that graph looks exactly like my mother graph would look. And I know that the normal graph of cos x would have a 1 here in front or nothing. And we know when there's nothing there, that means that it's a 1. So our B value is equal to 1. Okay. All right. Cool. So we've now answered question 4.1. 4.2, okay, it says here, for which values of x will g be a decreasing function? Okay, let's have a look at the graph of g, guys. The graph of g is the cos graph. It's the cos graph. When they say decreasing, they want to know which part of the graph is going down. Between which values is my graph going down? Now, look at it in this direction, guys. When we're looking at it in this direction, if I look at it from 0, right? If I start over here at 0 degrees, do you guys see that my graph is going down? Down, 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 down. Where does my graph of G stop going down? At which value? At which degrees does my graph stop going down? Ooh, not 90. Remember, Samuel, it's still going down over here. Good. Remember, Pachi, we're looking for values of x, and our values for x are over here. Where does my graph stop going down? At 180. And then it starts going up. Okay, so when they say for which values of x will G be a decreasing graph, it starts at 0, at 0 degrees, up until 180. Okay. So only the values in between 0 and 180 give us a decreasing graph. All right. Okay, cool. Everybody with me? 100%. Okay, here's the next easy question. What is the amplitude of F? Have a look at the F graph. How high up does my graph go? What is the amplitude of F? That's it. We don't need to add the negative. We know that the graph is negative, but F only goes up to 2. It goes, how high up does it go? It goes up to 2. So that's how high up it goes. Okay, our amplitude is 2. All right. Now, let's look at 4.4. 4.4 says, what is the range of G? What is the range of G? What are we calculating for? What are we looking for, guys, when we look at the range? Which values? Oh, not the X values, Pascal. I'll tell you that. Good. It's the Y values. Okay, good. It's the Y values. Right. So let's think about this. If we look at G, G is our cos graph, guys. Let's look at our Y values. My Y values of my G graph, my G only goes up until 1. And how far down does my graph go? How far down does my graph of G go? Up until which point? Good, up until -1. Okay, up until -1, there, we can see it there. There, between 1 and -1. So my pos graph, or my G, the graph of G, only goes in between -1 and 1. So when we write this, remember guys, we can either use set builder notation or interval notation. So we can say Y is an element of, and then I'm going to include -1 all the way up to 1. This is interval notation. If I had to write this in set builder notation, I would open my curly brackets, my squiggly brackets, and I'd say Y is an element of real numbers such that Y needs to be in between -1 included and 1 included. Close squiggly brackets. Okay. All right, give me a thumbs up if the range is ringing a bell. You remember seeing these kinds of
This
questions?
time,
before?
you must.
Oh, Pascal, don't put the round brackets. Remember, the difference between round brackets and square brackets, very, very important. Okay, very, very important. Okay, because if you put round brackets, that means we're not including -1 or 1 and -1, which means you're telling me there's a hole over here. There's a hole over here and there's a hole over there. No, 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 no. This thing includes the point -1. So we need to put the point there where -1 is as well. Okay. We need to include it. So you can't use round brackets, you need to use the square brackets. Okay. It's something that we do learn. We did it at the very beginning of the year. We were doing it when we were doing inequalities. Okay, so if you'd like, you can go have a look on the website, look at that particular section. Okay, have a look at that section where we talk about that. Okay, it's very important that we use square brackets instead of round. All right, good stuff. All right, guys, let's have a look at this question over here. Okay, it says here, for which values of x is f of x minus g of x equal to 2? Okay, so who can try and interpret this question for us? What do they actually want from us here? Does anybody know? Anybody have any idea what exactly do they want? Oh, okay, let me rather ask this. If you saw this question in an exam, would you know what to do? Yes or no? No, okay. Just give me 1 second, guys. Just need a second. Okay, all right. Let's think about this, guys. Let's think about this seriously. Okay, so they want us to look at where both of these graphs would be equal to 2, right? Or where the one graph minus the other would equal to 2. Now, let's think about this, guys. F of x is our sine graph, and g of x is our cos graph, right? So what they want us to do is look at where, when put together, they would give us the value of 2. So let's think about this. If I go to f of x over here, f of x over here is equal to 0, right? And my g of x graph over here is equal to -1. The distance between these two, how much is the distance between these two? Between that point 180 from here to there. What is the distance between those two? Yes, Pascal, correct. Correct. The distance between the two graphs at that point is 1. Okay, the distance is 1. From here to there is 1. Let's look at another point. let's look at the point here. From this point on my g of x graph to this point of my f of x graph, how far apart are these two things from each other? If I had to minus the one from the other, what difference would I get over here? That's it, Sandakake, that's it, Akaham, good. I would get 1, right? So what my graph is actually asking for okay, so the graph is asking me, where is it where when I minus the two graphs, I'm going to get a difference of 2. Can anybody tell? Look for a place along the graph where if I minus the two of them from each other, I'm going to get a value of 2. That's it. Amazing. Good. I know that between here and there, what is the difference between here and there? The distance there is, that one is at 0, my g of x graph is at 0, and my f of x graph is at -2. But the distance between them is 2. And that's exactly what my graph wants. That's what my question wants. It's asking me, where is the difference between the two graphs equal to a distance of 2? Right. Now, Asbonga has helped us out here. Asbonga has told us that at x is equal to 90. Anywhere else, guys? Anywhere else? X is equal to? Anybody else? Can you say? Yes. That's it. Good. There. That's it. They're at the point 270 over there. From here to there, I've got a distance of 2. There's a distance of 2 as well. So we've got 2 answers. X is equal to 90, and where x is equal to 270 degrees. Give me a thumbs up if that makes sense. Okay, I see somebody with their thumb like, no. Who's that? Tatu? Okay, where did I lose you, my sweetie? Okay, all right. So, Riabetu and Tatu, do you agree with me? Everywhere. Where did I lose you? I have to know where to find you. You can't just say I'm lost everywhere. Okay. Do you agree with me that f of x minus g of x means difference? Minus means difference. Yes or no? Yes? Yeah, good. We're on the same page. Difference. We're looking for the difference between the two graphs. Now, you'll agree with me that if I looked at this graph, the difference between this graph at 0 and this graph at -1, what is the difference between the two? That's going to give me 0 minus -1, because it's the difference. There's -1, there's 0. 0 minus -1 would be 1. Give me a thumbs up if that makes sense. The difference between here and there is 1. Does that make sense? Awesome. Okay, Rebet is saying yes. Okay, Patu, are you understanding though? I'm seeing the yo, but are you understanding what I mean? No, okay. All right, my sweetie, have a look here. This is my sine graph. Do we agree on that at least? This is my sine graph. Agreed? Good. Okay, so the sine graph is f of x, right? This graph over here, this is my cos graph. Agreed. Cool, we're on the same page. This is g of x. This is my cos graph. Excellent. Now, if I look at this point over here, what is my sine graph equal to over here? At sine of 180. At sine of 180, what is this equal to? Sine of 180 is equal to, this is actually -2 sine of 180, but it doesn't matter. Sine of 180 is equal to how much? Okay, punch it into your calculator, my sweetie. Pick up your calculator and type in sine of 180. Thank you, Samuel. I'm waiting for Patu to come to the party. That kind of rhymed. Patu to come to the party. Okay. Okay, Patu, are you with me? Good. It says 0, right? So you agree with me at that point, sine of 180 at f of x, sine of 180 is 0. Agreed? Now look at my cos graph. Go type into your calculator cos of 180. Cos of 180, because both of these graphs are at 180. Type into your calculator cos of 180. Tell me, what do you get? Thank you, teacher Naz. At least somebody thinks I'm cool. Okay, good. Cos of 180 is -1. Good, -1. So now if I minus these two things from each other, I'm going to get 0 minus -1. What will my answer be? 0 minus -1 will give me, not -1, Samuel, a negative and a negative will give me a +1. Good, 1. Everybody's with me, 100%, good. But that's not what the question, it's okay, it's okay. Okay, that's not what the question was. The question is asking me, go and find a place where if I minus these two things, they will give me an answer of 2. If I minus them from each other. Now, let's go back up here, right? Now, remember my graph of sine, f of x. My graph of f of x, remember we found what the answer for a is. We said that a is -2. So my f of x is equal to -2 sine of x. Now, I want sine of x at this point, at the point 270. So I'm going to go to x and I'm going to replace it with 270. So I want you to go to your calculator, type in -2 sine 270, close brackets, give me an answer. What does it give you? -2 sine 270, what's the answer we get, guys? Good, Asponge. Excellent. Good, I want everybody else to be with me. I don't want you guys to get lost. Okay, type it in, -2 sine of 270, how much do we get? Good, we get 2, excellent. Right, so at 270, my f of x is equal to 2, right? That's my f of x. Now, my g of x, this graph over here for g of x, we said that g of x is equal to cos of x. So I'm going to replace x with 270. So I want you to go to your calculator and type in cos of 270. Give me an answer. What does it say? Cos of 270 is equal to how much? Good, Siabonga, amazing. Good, Atahang, good, Agobakwe. That's it. The answer that we get is 0. Good, we're going to get 0. Okay, we're going to get 0 at that point. 0. Okay, now we have 2 minus 0. 2 minus 0 is equal to what? Oh no, why do I feel like I'm frozen? Good, the answer is 2, guys. Good, the answer is 2. Sorry, I think I froze there for a second. Sorry, guys, my internet connection is kind of unstable. Good, is 2. That's the answer that they want, right? So at which point, guys, at which value of x did we find these 2 and 0? Where did we find these two values? Which degrees did we use? Which degrees did we use to get the point 2 and 0? What did we use? That's it, 270. Now, that's why the answer that we've got over here is 270. Does that make sense? Okay, I can guarantee you, if you go to 90, over here, and you do the same, the difference between the two of them is going to give you 2 again. Okay, Hati, does that make sense? Yes, Pascal.
Ma'am,
Yes.
since they said that f of x, give us a point where f of x is minus g of x is equals to 2. In this diagram, where would we say f of x was equals to g of x?
F of x is equal to exactly where they cross each other. Okay, so it would be here, at that point, and at that point. That's where they would be equal to each other. I think it would be at the point 1 and -1, but I can't make that assumption. Okay, I can't make that assumption. I would have to calculate. Okay, but at the moment, when they're equal to each other, it's where they cross, where they intersect. Okay, does that make sense, Pascal?
Yes, ma'am. Thank you.
Beautiful. That's a grade 11 question, by the way. They don't ask those kinds of questions.